In the beginning, railways were conceived as open roads, like the turnpikes. Policemen were employed to regulate the traffic where required. However, as locomotives and rolling stock developed and became heavier, it was realised that some effective means of spacing the trains was required. A system of time interval was developed using line-side signals. The railways soon found to their cost that this system had inherent dangers and that a space interval, or block, was what was really needed. The invention of the electric telegraph afforded reliable communication between signal boxes, and this led to the introduction of a system that was to become the basis of railway signalling for over a century, the absolute block system. Let's have a look at how the absolute block works. The signal box today has a home signal and a section signal. The section of line between these two signals is known as station limits. In advance of this section signal, the line as far as the home signal at B is known as the block section. Only one train may ever occupy this block section at any one time. This then is the basis of the system. As at A, the line between the home signal and the section signal at B is also known as station limits. Of course, either A or B might have more than two stop signals for each line. In such case, station limits extends from the outermost home signal to the section signal. Each signal box has a distance signal. This cautionary signal, placed at a braking distance from the home signal, can only be cleared when all the stop signals for that line have already been cleared. Now let's have a look at how a train is actually signalled on the absolute block. The signalman in the rear calls the attention of the signalman ahead, one beat on the block bell. When this call attention is acknowledged, the signalman in rear offers the train forward by bell code. If the signalman ahead is able to accept the train, he repeats this bell code and turns the commutator of his block instrument to line clear. This indication is repeated in the rear signal box. The signalman there is now able to clear his section signal for the train to proceed. When the train passes into the block section, the rear signalman sends the train entering section bell code to the signalman in advance, who acknowledges and turns the commutator to train on line. The train has now arrived within station limits of the signal box ahead. Only when the train has passed the clearance point or overlap as shown in the absolute block regulations, and the signalman has seen the tail lamp and thus knows the train to be complete, may he call the attention of the signalman in the rear and give the train out of section bell code, restoring the block instrument to the normal position. He may now accept another train. If the block section would be so long as to unduly extend the headway, a special signal is used to divide the section into two parts. This signal is called an intermediate block home signal and is usually controlled from the signal box in the rear. An intermediate block home signal can be identified by a rectangular white plate bearing a vertical black band. The system of signalling known as absolute block is normally associated with mechanical signals of the semaphore type, although in many cases colour light types are employed, particularly for distant signals. Let's begin by looking at some mechanical signals. Most common are the semaphore types known as upper quadrant. The signal arm is horizontal when the signal is at danger, or in the case of a distant signal at caution, and is raised through 45 degrees when the signal is cleared. A less common type, found principally on the western region, is the lower quadrant type, the arm of which is horizontal when the signal is at danger or caution, and is lowered through 45 degrees when the signal is cleared. Mechanical signals are usually operated by a system of wires and pulleys, and the actuating levers in the signal box are interlocked with each other as well as with those operating the points, so as to prevent conflicting movements being signalled in error. There is also some electrical locking, such as the lock on the section signal lever, preventing movement of this lever if the block indicator is not showing line clear. Where such electrical lock is fitted, the signal lever has a white band painted on it. Over the years, various devices have been employed to assist in reminding the signalman of the presence of a train. One of these is the simple track circuit, denoted by a white diamond sign attached to the signal post. Let's look at the simple track circuit, one of the most important developments in the history of railway signalling. A low voltage current is fed to the running rails by a battery. This current flows along one running rail as far as an insulated block joint. From here, the current flows through the coil of a relay, then back to the opposite running rail, through which it returns to the battery. While the current flows through this circuit, the coil of the relay is energized and the track occupation indication in the signal box shows the track to be clear. When the first pair of wheels of any vehicle passes onto the track concerned, the current, instead of flowing through the whole circuit, will take the short route and the relay will become de-energized. The track indication in the signal box will now show occupied. If, for any reason, there is an interruption in the flow of current through the track circuit, caused, for example, by a broken rail, the track indication will show occupied. It is therefore a fail-safe system. If the relay is used to switch the aspects of a signal placed in the rear of the track circuit, we have a simple automatic signal. Now the occupation of the track circuit is not only indicated in the signal box, but the signal is automatically restored to danger behind the train. When the train clears this track circuit, the relay will become re-energized and the signal will, once again, show a proceed aspect. Here we have the basis of modern track circuit block signalling. Every signal section comprises one or more track circuits. Signals are controlled by the passage of trains if they are automatic, or restored to danger by the train if they are controlled. Because the occupation of each track circuit is visible to the signalman, it is no longer necessary to offer trains forward as in the absolute block system. They are simply described forward to the next signalling centre. As with the simple track circuit, the system is fail-safe. Any interruption in the flow of current through the track circuit will result in the replacement of the protecting signal to danger. Although mechanical signals are still to be found in some track circuit block areas, the system is almost universally associated with multiple aspect colour light signalling. This may be of the 2, 3 or 4 aspect arrangement according to line speed, signal spacing and headway characteristics. Let's have a look at the sequence of aspects displayed by each of these arrangements. In 4 aspect signalling we have a green aspect, line clear. two yellow aspects, preliminary caution, expect to find the next signal exhibiting a single yellow. The single yellow aspect, caution, tells us to expect to find the next signal at danger. The three-aspect arrangement has no provision for displaying preliminary caution, the sequence being green, one yellow, and red. Certain areas have multiple aspect signalling of the searchlight type. These may be of the 3 or 4 aspect arrangement. Two-aspect signalling does not provide for a cautionary aspect on stop signals, and therefore these signals are preceded by a two-aspect colour light repeater, sited at braking distance in the rear. The colour light repeater displays either a green or single yellow caution aspect. Where any stop signal cannot be sighted at a distance by the driver, perhaps because of curvature or an overbridge, a banner repeater signal is provided. Most of these are of the mechanical type, although some have been replaced by the fibre optic display. When the black band is displayed at 45 degrees, the signal ahead is showing a proceed aspect, either cautionary or clear. When in the horizontal position, the signal ahead is at danger. Now let's take a look at how signals are identified. The automatic signal, the one controlled purely by the passage of trains, is identified by an oblong white plate bearing a horizontal black band. The semi-automatic signal, which is normally controlled by the passage of trains but can be controlled from a signal box or ground frame when required, is identified by an oblong white plate bearing a horizontal black band above which is the word semi. The controlled signal carries only a plate indicating the signal box prefix letters and the signal number. Finally, the colour light repeater is identified by a plate bearing the number of the signal which it repeats, accompanied by the prefix D or suffix R. Lines operated by track circuit block may be unidirectional in the usual way, or they may be reversible, that is to say, signalled in both directions. A further development of this capability is where a double-track main line has each road signalled for bidirectional running. With the provision of trailing and facing crossovers at regular intervals permitting trains to cross from one running line to the other, a high degree of operating flexibility is assured. The signalling philosophy of British Rail is that of route control rather than the speed control system used by the railways of continental Europe. Drivers of trains are advised of the route over which they will be running, and this route information is given in 3 different ways. Firstly, in mechanical signalling by semaphore arms placed at different heights on a bracket or gantry. The highest semaphore arm routes trains to the main line. The divergent routes to the left and right are signalled by semaphore arms in descending height. Secondly, by means of groups of 5 white lights above the main signal head, angled to conform to designated positions. Let's have a look at how this works. The junction indications are given position numbers, so, starting at the top left, we have positions 1, 2 and 3. Then from the top right, positions 4, 5 and 6. With a proceed aspect and no junction indication, the train is routed via the main line. Junction indication position 1 routes the train to the first diverging track to the left, position 2 to the second left, and position 3 to the third left. Junction indication position 4 routes trains to the first diverging track to the right, position 5 to the second, and position 6 to the third. Obviously, where a junction signal is required to indicate more than 7 routings, the maximum possible with standard junction indications, an alternative system must be employed. The so-called theatre-type route indicator is capable of exhibiting an almost unlimited number of numerical or alphabetical combinations. A common location for this type of junction indicator is at the approach to large stations having a number of platform lines. The most modern form of theatre-type indicator uses fibre optics to give a bright, high-resolution dot matrix display. This technology has also been used at some locations to replace standard 5 white light junction position indications. An R or RA indication is also given at some platform starting signals to give authority to the driver to start the train. In colour light signalling, where a divergent route is set which is subject to a speed which is restrictive by more than 10 miles per hour, a system of approach release is applied to the junction signal. In this system, the junction signal will not exhibit a proceed aspect until the approaching train has occupied a berth track circuit for a given interval of time. By this means, the retention of the junction signal at danger controls the speed of the train as it approaches the divergent connection. A more recent development has been the introduction of flashing yellow aspects to regulate the approach speed of trains to high-speed divergent junctions. The flashing yellow aspects will only be displayed where the divergent route is set. Let's go back and have another look. Where 4-aspect signalling is employed, the advance warning of approach to a divergent route will be 2 flashing yellow aspects. The next signal will display a single flashing yellow, and the junction signal itself may display a single steady yellow aspect with junction indication for the route set. In this case, drivers must expect to find the next signal at danger. So far, we have looked at the systems of signalling and types of main running signal. Now we must look at the many other types of signal used on British Rail. Let's begin with the shunt signal. This type of signal is usually ground-mounted and when cleared permits movement towards the next signal but at a speed from which the driver may stop short of any obstruction. The move is therefore cautionary. These signals usually control movements to or from the main running lines or from one running line to another. When cleared, this signal displays 2 white lights at 45 degrees. Many shunt signals throughout the entire system are of the mechanical disc type, and although there are some regional variations in detail, the display is essentially the same. By day, this type of shunt signal exhibits a red band horizontally when at danger, and at 45 degrees when cleared. By night, these signals show a single miniature red aspect when at danger and a miniature green aspect when cleared. Where these signals are stacked one above the other, they give route information, reading top to bottom, left to right. Before leaving the shunt signal, we must look at a special form of this signal often placed at the outlet of a yard or depot. This special type of shunt signal, if of the position light type, displays 1 yellow and 1 white light horizontally when at danger. However, when in this position, the signal may be passed by a driver making a movement within the yard or depot. It is only necessary for the signal to be cleared for a movement towards the main running lines. When cleared, of course, it displays 2 white lights at 45 degrees. There is a mechanical disc version of this special shunt signal which displays a yellow horizontal band on either a black or white ground when at danger. It turns through 45 degrees when cleared in the normal way. Now let's look at some position light signals mounted below main running signals. These position light signals are normally out. When cleared, they display two white lights at 45-degree disposition. Such signals are used for draw-ahead movements or permissive working on platform lines. Let's have a look at permissive working on platform lines in detail. At locations where passenger trains are required to enter a platform line already occupied by another train, for example, where two separate portions of a train are to be coupled, the driver will be stopped at the signal protecting the rear of this line. After having stopped, the position light signal will be displayed together, if necessary, with route indication. The driver may now draw forward at caution, entering the platform line, but stopping short of the rear of the train ahead. At some locations, mechanical signals are still used for draw-ahead and permissive working on platform lines. Although there are some regional variations, these signals usually take the form of miniature semaphore arms placed below the main running signal. By night, they display a white aspect when at danger and a small green light when cleared. Finally, a most important type of ground signal is the limit of shunt. This signal may take the form of a white floodlit board on which are inscribed the words limit of shunt or shunt limit. Or they may take the form of a position light displaying two red aspects horizontally. Limit of shunt signals must not be passed under any circumstances. Many years ago, it was recognised that some form of repetition of the signalling was necessary in the driving cab. British Rail developed the automatic warning system to satisfy this requirement. Where the automatic warning system is provided on track circuit block lines, the approach to each signal is marked by two magnets in a housing in the 4-foot way. The first of these two magnets is permanent, and via a receiver mounted on the train, it provokes a caution indication to sound in the cab in the form of a horn tone. However, if and only if the signal is showing a green aspect, the second magnet and electromagnet will be energized, preventing the cautionary indication from taking place and provoking instead a bell to sound. Together with these audible indications, there is a visual indication placed on the driver's control desk called the sunflower. When passing over each AWS housing, the permanent magnet will cause the indicator to display yellow and black segments. If the second electromagnet is energized, the signal will display a green aspect. The indicator will change to an all-black display. When the cautionary horn tone sounds, the driver has 3 seconds to cancel this indication by depressing the AWS cancellation button. Should he fail to do so, the system will provoke an emergency application of the automatic train brake. Where the automatic warning system is applied to lines worked by the absolute block or electric token block systems, only the distance signal is provided with AWS equipment. Permanent magnets, giving a cautionary indication only, are placed at the approach to automatic open crossings and to permanent and temporary speed restrictions. On single lines where the AWS equipment may be approached in the wrong direction, a line-side indicator is placed to advise the driver that he will need to cancel a cautionary horn tone. On certain urban passenger lines, predominantly those operated by London Underground and Merseyrail, a mechanical means is provided for provoking an emergency brake application should a train pass a signal at danger. This system is known as the train stop and consists of an air-worked T-piece alongside the running rail. Normally held in the raised position, it is lowered by compressed air when the signal clears to a proceed aspect. A device mounted on the train, called a tripcock, should normally be in the set position, pointing down so that it will come into contact with any raised train stop. The tripcock is a simple device which, if struck by a raised train stop, will vent the train brake pipe air to atmosphere, causing an emergency brake application. Because the train stop is held in the lowered position by compressed air when the signal is cleared, it is a fail-safe system. To ensure that all trains working over train stop fitted lines have their tripcocks in the set position, tripcock testers are positioned at strategic locations. The occupation of an approach track circuit causes the TT display to become illuminated. When the tripcock makes contact with a proving ramp, the TT display is extinguished, proving the tripcock to be in the set position.